it a uniform distribution, or distribution. Many of you guys are in the middle on this one. Looks like was what we talked about. We looked at the data sets, including variation. So we found the mean, the median, the standard deviation, variance, all that stuff was happening in Chapter 3. Chapter 4, we looked at the principles of probability. And in Chapter 5, we looked at discrete probability distributions. Well, we're going to start looking at continuous probability distributions, or continuous distributions that we're looking before. Chapter 3 we found z-score. Remember the z-score represents the number of standard deviations that a given value is above or below the mean. And so when we were trying to find if is deviation if I had that minus the mean sigma, it could be, or an S. Then you took your score divided by the number of standard deviations. So if we looked at this one, minus 5. Oh, or negative. It was 2 standard deviations below the mean. If, on the other hand, taking minus the 6, the z-score of 1 is 1 standard deviation of a comparison to how many it was. We're representing if it was representing below. Now, not had a regular. Today we'll start looking at why we do that. But that was one of the things that we talked about, was looking at how many deviations above and below the mean we were. The z-score is going to be a huge piece that we're going to be talking about in this chapter. So it's going to really spend some time recalling what we've already done with the z-scores. 6. Continuous. So if it's a decimals, you're not just jumping from to 3 people. You could be those fractions in essence of 101.46. Of something. Where you would have all those fractions, there's no value to another. We're also focusing on the normal distribution. Remember, this normal curve. The maximum in the middle, which your mode would all be the same numbers if it's the same shape where it has. Is this fortunately for you, this is an this equation you working from using that distribution. Fixed values of a mean is typically deviation, again, population standard deviation, pi obviously is a constant. E page 7128, and that is that relationship. Relationship. E is another one of those applications. Quick. Random variable has a uniform value. And they had a probability. The probability minute, the probability 14 minutes is all going to be the same changes. Has that. So this would be an example of the probability. Or you might have 15 minutes. So that probability is a uniform. Concept. Moment. Anywhere between that 0 and 15 minutes you might wait. Following the curve on the 0, what those are saying. Because all of the a total probability of 1 because all possibilities are represented. And if we look at your x value, it was saying that every here. I can't have an then if we're talking that the total area density curve has to be to be 1, and that the probability going to happen even area under this curve is going to still probability when you're looking at doing this. Beam 0 or probability. These two things have a relationship when we're talking about these density curves. There to our, this one illustrated selected 100. So, 25 points exactly stay the same. If I wanted to find selected here is 5. That 5. 4 points. If we go back to our example for the bus, weight between I'm wanting to know what's probably going to fall weight between 5 and 8 minutes. Well, this is going to be what my area. Chance that if this was a schedule every 15 minutes, then I'm going to have a 20% chance that I'm going to wait between 5 and 8 minutes. Questions there? So again, that area and the probability have a good relationship. It's definitely one of those relationships we're going to use a lot. It's easy to find the area of a rectangle. Understanding that's going to be helpful. So we have to go back further than I realized. We're going to be distributions here for you can use the, but it's the same idea. Is a normal probability distribution with a mean of 0 and standard deviation. The area under its is now. This is the it's not a normal distribution. Standard normal distribution is even more specific. Standard normal distribution has your mean. If you're going to one standard deviation, it has that set value of how far has that connection that within one the values fall. 95 of the values fall. That relationship that we back in we're doing this. We're trying to find our probabilities. Try to find the area under that curve with that equation. Table A2 is one of the tables that's in that nice little handy-dandy reference. Also in the back of your book. So in the back of your book you have on your test is table A2. When we look at finding these, it tells me it's how we do these. Or sorry, I said that wrong. The vertical values along the left side is your z-scores. Hold up the decimal after the second decimal, so the 100th place goes across the top. So if I was trying to read these, I'd be reading cards to be able to find where those z-scores are. But it helps us to find the areas under our different curves. So, for example, looking at, if I want to across the side, 3.2 here, that hundredths place here. That probably find. And so what is this coming up with? Point zero zero three. Those. So, looking at some characteristics of this table. First of all, it is designed standard and a standard. Looking at data of 0 and a 4 to have a standard deviation of 1, we're going to have to be so we'll be looking at how to convert the same table every time a little bit distribution. So it's when that has been so looking positive z relative area from going to be recognize that you're always giving you the area to the left of that. I wanted to know. We'll have to figure out. Also, when working with confusion between the z-score and B and Z, is the distance along the distribution. So just what's given to you along the columns on the side. Everything that's in the middle is your area. Z is my negative for the probability more than 3 standard deviations below the probability would be very, very small. Underneath that curve, this area of what's shaded is your again, negative 2.83, so still actually how far along the horizontal axis it is. If I'm that 0.23. Of a Z. Finding the probability. Inside the all this stuff. Standard deviation. Z have to go across or along this along across the top to find that one. A is less than Z is less than probability that our Z is between A. So I think less than A, this is the one. Green, Z is less than A. Fine, if you can. How can I? Z is greater. Z less than the table. Under our couple more. This time use the positive Z-score table. Z is should just get the board system. We do some of these. What for the left? Because for this area left, the area to the left of one, that is what does the table give us? So if we cut
the 8 across the top. It's going to be point. Okay, 0.9761 should be the area we're coming up with. So, think about points. Within 2 standard deviations, values at that point. You got to find this one then. If we want to find the end. Greater than. Now, for not that much, I probably am a little too close. My marker wasn't matching up. I am too. It's still not much above 0. How much it is above 0? If this is if it's below. It's so I'm look at I want my okay, subtract. So we're getting a value that's just a because a chunk of things that part there. What the problem 1.7. I want the area between tells as I read 0.7. Figure out what's 1.2. You guys think? 1.2. The 0.8. How about 0.7? Disagree, Sarah. You guys are agreeing. To the 1.7 area left. Area between. Point 2. It's telling me the point 2. Keep going. Okay. Do is I want to take everything that's of one stop at 1.2, subtract out. That makes sense? It's green without the stuff that's minus 4. And when you do minus 1.2 and figure out the area to 0.5, because that would give you a completely changing what you aren't a nice uniform distribution. All right, news for the weekend. Homework. Three and so it's not to do homework thing. Next test.